Hello everyone. In this video, we are going to discuss about the some of the system components required for execution of the firmware process. That is the first one is a reset circuit. The reset circuit is essential to ensure that the device is not operating at voltage level operate during the system power on. When the device is on, guaranteed to power on system. The reset circuit is essential to ensure that the device is not operating at the voltage level. The reset signal brings the internal registers and the different hardware systems for the processor to controller to know the state and starts the firmware execution from the reset the vector interrupt table. This is the vector interrupt table, total interrupt vector table we are setting the reset signal can be either active high or low, either 1 or 0. The reset signal to processor can be applied at the power on through an external passive reset circuit compa compressing a capacitor and the reset are through a standard reset IC like MAX 810 from maximum dials. The reset signal is a process can be applied at the power on through the external passive resistive circuit. This is an external circuit added to the your system. The processor behavior may not be uh, predictable if the power supply voltage falls below the recommended operating voltage. It may lead to simulate like data corruption. At the time it occurs, the data corruption is occur. In this one, how to see the RC based reset circuit. So in the embedded system, in the in embedded system, the reset circuit is used to allow the device in the operating at the particular voltage level. The particular voltage level when the system is on state, that it performs a firmware execution from the reset vector, that is a vector address at 0x00. That is the starting point of the vector address, starting address of the vector interrupt vector table, that is at 0x00. When the internal register and the different hardware system of processor, different hardware system in the processor or controller are at prescribed state. The reset signal has two states, that is active low and active high, based on your prediction circuit. The reset circuits are generally connected to configurations on external and internal. In the internal configuration, the reset signal is applied to the processor when the switch on using an external passive resistive circuit. Reset circuits are generally connected to the two configurations, that is external and configuration and the internal configuration. The reset signal is applied to the processor when the switch on using an external passive circuit. On the other hand, an initial configuration, the microprocessor or a controller contain an inbuilt reset circuitry which is depending on the clock signals that synchronized to a processor operation. Internal there is a reset circuit is there for that is depending on the signals that synchronize to the processor microprocessor operations. RC based circuit has a active high and low configuration are in the figure you have to see. By varying the resistive and the capacitive values of RC reset circuit, pulse width is adjusted. Pulse width adjusted means clock pulses are adjusted based on that one. Based on that, the reset conditions are taken place. Based on clock inside there is a controller or a processor, inside there is a reset circuit is there that is operating at the operation generation of clock pulses in the circuit. The clock pulses generator, there is internal for every controller or a processor there is an internal some crystal oscillator is there to generate the clock pulses. That is clock pulses are used to move the data from one place to another, and after processing, and the speed also defined based on the generation of the clock pulses. So these are the reset circuit, about the reset circuit, and this is one of the essential component in your embedded system. So thank you.